Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, I would like to discuss about the relationship between the binomial distribution and also the Poisson distribution. So if you still remember, in my previous video, I already discussed about the binomial distribution only and also the Poisson distribution only. So right now we are going to discuss about the relationship, okay, between binomial and also Poisson distribution. So here are the objective for this subtopic. Okay, the first one. I want student must understand the problem regarding relationship between binomial distribution and also Poisson distribution. Second one, everybody must know how to find the probabilities for outcomes variable using the relationship between binomial distribution and also Poisson distribution. And last but not least, I want everybody must know how to calculate the mean, variance, and also standard deviation for the relationship between binomial distribution and also Poisson distribution. Alright, so let's start with the introduction. Regarding the relationship between binomial distribution and also Poisson distribution. Okay, we go to the theorem first. If x is a binomial random variable with parameters n and p, then for each value, x start from 0 until infinity, as p close to 0 and also n tend to infinity, with n multiplied with p approximately close to lambda constant. So the formula is limit x to infinity and x multiplied with p to the power of x multiplied with 1 minus p to the power of n minus x, where this one approximately close to exponent to the power of minus np multiplied with np to the power of x over x factor real. So if you still remember, actually this formula is come from binomial formula. Binomial formula. Okay. While this formula comes from the Poisson formula. Okay. So this is the formula that we will use in this topic where the relationship between binomial and also Poisson distribution. Actually, we can use this formula only. Alright, so we have a rough guideline regarding to this subtopic. So in some reference books, a rough guideline is provided, namely the Poisson distribution approximately to the binomial distribution, where the guideline should satisfy this condition. Okay, the first condition, the value for n must greater than 50 and the value for p must less than 0.1. Okay, and if you calculate, okay, n multiplied with p, it must be less than 5. And you must remember, this is just a rough guideline, because there are some of therefore some of the book, okay, will use, okay, the different value for n and also p. Alright, let's start with the example number 1. Okay, records show that the probability is 0.0005 that a car will have a flat tire while crossing a certain bridge. By using the Poisson distribution, approximate the binomial probabilities that among 10,000 cars crossing this bridge, please calculate exactly 2 will have a flat tire and second one at most 2 will have a flat tire. Okay, firstly, let's list down all the information that we have. Okay, firstly, we have this one 0.0005. Okay, that means P is equal to 0.00005. And then we have a 10,000 cars. 10,000 cars, that means N equal to 10,000. So, and if we look at these two information already satisfy the guideline, the rough guideline for relationship between binomial and also Poisson distribution. Okay, so firstly, let's calculate our lambda. Okay, lambda actually approximate equal to our NP. So we multiply 10,000 with our P 0.00005. So we will have lambda is equal to 0.5. Alright, so now let's start with question number 1. Okay, so the question asks you exactly 2 will have a flat tire. That means the question asks you to find probability X is equal to. So what is the formula for Poisson distribution approximate to binomial distribution? So the formula is probability X equal to X is exponent to the power of minus NP multiply with NP to the power of X over X factorial. Or we can also write as exponent to the power of minus lambda, lambda to the power of X over X factorial. Okay, so since we already have the value for lambda, okay, so let's substitute the information that we have in our formula. So exponent to the power of minus 0.5 multiply with 0.5 to the power of 2 divided by 2 factorial. Okay, then you just use your calculator. So probability, okay, exactly 2 will have a flat tire is equal to 0.0758. Okay, so this is for question number 1. Okay, so now let's move to the question number 2. Okay. So question number 2, at most 2 will have a flat tire. That means the question asks you to find the probability. Okay, since the word at most, that means it will start from X equal to 0 plus probability X equal to 1 plus probability X equal to 2. Okay, so just substitute into the formula. Okay, exponent minus 0.5 multiply with 0.5 to the power of 0 over 0 factorial plus for x is equal to 1. Exponent minus 0.5, 0.5 to the power of 1 over 1 factorial, and lastly plus probability. Okay, x equal to 2. Actually, probability x equal to 2, this one we already calculate at the question number 1. So plus 0.0758. Okay, so you just use your calculator. So the answer for at most 2 will have a flat tire is equal to 0.9856. Okay. Alright, now let's go to the example number 2. Okay, so if 0.5% of the books bound at a certain binary have defective bindings, use the Poisson approximation to the binomial distribution to determine the probability that 5 out of 400 books bound by this binary will have the defective bindings. Okay, so firstly, let's list all the information that we have. Okay, so firstly, we have the value for P. Okay, so P is equal to 0.5 over 100. Okay, because 0.5%. And then we also have the value for N is equal to 400. Okay, and if we recall back the rough guideline for Poisson distribution approximate to binomial distribution, the value for P and N already satisfy the condition. Okay, so from here, let's find our lambda. Lambda, okay, approximate equal to NP. Okay, approximate equal to N is equal to 400. Multiply with P 0.5 divided by 100. Okay, so by using our calculator, we will have 2. So lambda is equal to 2. Then the question asks you to find probability that 5 out of 400 books, okay, bound by this binary will have defective bindings. That means the question asks you to find probability X is equal to 5. So substitute into our formula. Okay, exponent to the power of minus 2 multiply with 2 to the power of 5 divide by 5 factorial. So by using our calculator, so probability x is equal to 5 is equal to 0.0361. Alright, now let's try for example number 3. Okay, in a given city, 3% of all licensed drivers will be involved in at least one accident in any given year. So, by using Poisson approximation to the binomial distribution, determine the probability that among 150 licensed drivers randomly choosing in the city, first one, only 5 will be involved in at least one accident in any given year. And the second question asks you to find the probability at most 3 will be involved in at least one accident in any given year. Okay, so from the problem, okay, the information that we have is our P. So P is equal to 3 over 100, okay, because 3%. Okay, and then we also have the value for n. N is equal to 150. And these two value already satisfy the rough guideline for Poisson distribution approximate to binomial distribution. Okay, let's calculate our lambda first. Okay, lambda approximate equal to NP approximate to 150 multiplied with 3 over 100. So I will have the value for lambda is equal to 4.5. Okay, so now, okay, let's start with the question number 1. The question number 1 asks you to find only 5 will be involved in at least one accident in any given year. That means the question asks you to find the probability when x is equal to 5. So substitute into the formula exponent to the power of minus 4.5 multiply with 4.5 to the power of 5 divide by 5 factorial. So just use your calculator. So you will have 0.1708. Okay, for question number 2, the question asks you at most 3. That means the question asks you to find probability x less equal to 3. Or in other way, we can calculate for probability. Start from x equal to 0 plus probability x equal to 1 plus probability x is equal to 2 and plus probability x equal to 3. So by using the formula, you just substitute all the information start from x0 until x equal to 3. So the probability is equal to 0.3423. So I hope everybody can understand my explanation about this subtopic. So all the best and thank you guys. Assalamualaikum.